Find the values for a and b such that f is continuous on the interval from negative infinity to infinity. Well, we have f of x being equal to a times x squared plus x minus b for x values less than or equal to 4. We have it being equal to ax plus b for x values between 4 and 7, not including 4 and 7. And it's equal to 3 times ax minus 6 for x values greater than or equal to 7. Well, in order to make this function continuous, the outputs or function values need to be the same when we are at the endpoints of our various pieces or within the domain endpoints. Like this, when I put 4 in, this piece would have to equal this piece as its output. So we can actually set these two pieces equal to one another. So we have ax squared plus x minus b is equal to ax plus b as one section, and it has to be true when x is 4. So we can then substitute 4 in for x, and when we do that, we will have a times 4 squared plus 4 minus b is equal to a times 4 plus b. And when we evaluate this, we will have 16a plus 4 minus b is equal to 4a plus b. All right. And then we can't simplify that. Well, actually, we can simplify it further. We can move the a's and b's to one side and move the constant to the other side. So when we do that, we'll subtract 4a and we'll have 12a. When we subtract another b over here, it'll be minus 2b. And then if I subtract 4 to the other side, it will be equal to negative 4. So this is one equation that we have in a simplified form. The other critical value that we need to have our function values be equal are the second and third piece when x is 7, because that is the domain point, or that critical point in the domain where these two have to be equal. So let's set those equal to one another and see what we have. So we have ax plus b is equal to 3ax minus 6, and these have to be equal when x is 7. So let's substitute 7 in. So we have a times 7 plus b is equal to 3 times a, and then x is 7 minus 6. And when we simplify this further, we'll have 7a plus b is equal to 21a minus 6. If we subtract 21a to this side, we will have negative 14a plus b is equal to negative 6. So we have two equations here with a and b in them, or we have a system of linear equations. Question is, how do you want to solve this? Do you want to use elimination or substitution? Doesn't really matter. Actually, since b has a coefficient of 1 here, we could actually move the 14 back over to the right side and have b being equal to 14a minus 6. And then we can take this 14a minus 6 and substitute it in over here. When we do that, we'll have 12a minus 2 times 14a minus 6 is equal to negative 4. So we'll still have 12a, then we'll have minus 28a plus 12 is equal to negative 4. If we combine the a's together, we'll get negative 16a, and if we subtract 12 to the other side, we'll get negative 16. So a is going to be equal to 1. And then if we substitute 1 back in for b, we'll have that b is equal to 14 times 1 minus 6, which is 8. So A is 1 and B is 8. That's answer choice A. Show that there.